आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, let's start the question. The question says that write down the functional isomers of carbonyl compound with molecular formula C3H6O. Which isomers will react faster with HCN and why? And explain the mechanism of the reaction also. With the reaction leads to the completion with the conversion of the whole reactant into product under reaction conditions. And if a strong acid is added to the reaction mixture, what will be the effect on concentration of the product and why? So here, as we know that here the two isomers are formed with this C3H6O. So let's write that. So here we have C3H6O. So from this, here we get CH3, CH2, CHO. So this is the aldehydic group, and here we have CH3CO, CH3. So this is propanol. Here we have propanol, and this is propanol. Propanol. So in then this propanol reacts faster with HCN because there is a less steric hindrance and electronic factors which increases its electronegativity. So here in this case the mechanism for the reaction to be carried out here the reaction is carried out in the presence of base which acts as a catalyst. So here when this HCN reacts with OH negative, then the base remove a proton from hydrogen cyanide and readily produce Cn negative ions and make the reaction fast. So here H2O plus here Cn will produce, and this is a nucleophile. Here this is a nucleophile. So in actual practice, this HCl needed for the purpose in production in situ by the action of dilute mineral acids on sodium cyanide. So here is the mechanism for this reaction will become. So the reaction is believed to produce as follows. The positively polarized carbon of carbonyl group is attacked by a strongly nucleophile Cn. So here this is C double bond O plus Cn negative. So in this case the polarized carbon, so this is the polarized carbon of carbonyl group is attacked by nucleophilic Cn. So it is attacked by this nucleophilic Cn with simultaneous transfers of pi electron of oxygen. So here the transfer of pi electron of oxygen. The oxygen then combined with H plus ions. So from this here we get CO negative, and here we have Cn, and here. So after that this oxygen then combined with this proton to give a cyanohydrine. So here we have the structure of cyanohydrine, that is COH. Here we have Cn, and then so this is the structure of cyanohydrine. So let's see the reaction of aldehyde here. So the cyanohydrine are the useful compound in organic synthesis. So this can be prepared many other organic compounds such as alpha hydroxyic acid, alpha beta unsaturated acids, amino acids. So here let's see the reaction when this aldehyde CH3 C double bond OH reacts with HCN. So when this reacts with HCN, this will give CH3COH CnH. So this is a here this is a cyanohydrine. So on hydrolysis, then it will give a lactic acid. So this is the structure of lactic acid. CH3COH, here we have H and COOH. So this is a lactic acid. Lactic acid, it is also known as alpha hydroxy acid. Alpha hydroxy acid. So now here the third part is also given to us. So in third part is given that, let's see the third part here. Here, if a strong acid is added to the reaction mixture, what will be the effect of concentration of the product and why? So in this case, if strong acid is added to the reaction mixture, the reaction is inhibited. So here we can say that the reaction is inhibited. Because the production of CN ions prevented. Because production of CN negative ions prevented. So this is the answer for this question. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।